So tonight we're going to do chain rule. In a couple of seconds I'm going to show you kind of an easy, a medium, and a hard example. And you can decide, just let me know down in the comments. So remember, when you're watching these, if you need to, just hit the pause button and go back, or just rewind a little bit, because you can watch these as many times as you need to. So in any event, it's time to get started. So let's talk about the chain rule. Chain rule comes from the need to do something a little bit different. So if you're looking at this expression right here, let me point to it. Ordinarily, you would have just, because it's squared, you would write 2x plus 3 times 2x plus 3, maybe FOIL that out and then differentiate it term by term. And that works out great when you have a square here. However, suppose this was 2x plus 3 to the 20th power. Do you want to FOIL this out 20 times? I mean, you could, and you could do it term by term, differentiate it, and you would get the derivative. But is there an easier way to do it? And that's what we're going to look at in this example. So here's the formal chain rule. It looks like this. If you have a function, we'll call it h of x, and it is equal to this composite function, f of g of x, the derivative of h prime of x, is equal to the derivative of the function of the embedded function. The chain is what we call this. This is a composite function. So f prime of whatever this function is, then we multiply by the derivative of this function. So that is, in a nutshell, how we do this. But this is often called the chain. I call it the chain to my students. I'll call it the chain here. So let's look at a couple of examples. Okay, so here's kind of a not too hard one to look at. I have a chain right here. This is our g of x, right? Or what we call the chain. So I'll jot that down. So what I always teach students is to think of this as though it's some big variable. So I'm going to say that's f of x to the, keep it the same color, x cubed. Right? Because we have a embedded function here, a chain. I just noticed I put my chain the wrong way. All right, so, but if we treat this, just pretend it's a power rule. This is one big variable here, x cubed. So if I were going to take the derivative of this, it says to take the derivative and then multiply by what's inside. So think of that as just a little bit more drawn out power rule. So we all know that we could write 3x squared. But what is this x again? This x is, right here, 3x minus 2x squared. So this is how I would do this. I would say, f prime of x is going to equal 3 times whatever this big x is right here. So it's still going to stay 3x minus 2x squared. We don't touch the chain until we're done. Now, if this was a power rule, we're going to change the 3 to a 2. So change this 3 to a 2. So let's write that in. Now, let's take one more step. The step is take g prime of x and multiply it by what we just did. So what is the derivative of what is inside here? Right? 3x minus 2x squared. So I would just say 3 minus 4x. And yes, this does have to be in parentheses because this is one term. If I multiplied it by 3, that would be a term, and then I'd be subtracting 4x. So that's not what we're doing here. Okay? So let me show you another quick example like that. Suppose, come down here, suppose that f of x is equal to, 3x cubed plus 4x minus 1, and that is all raised to the, 15th power, right? Something that's definitely too big to expand for us. Could I expand this trinomial 15 times? Of course I could, but that would be a lot of work. But we're going to use calculus, and we're going to say that the derivative is, treat this like it's a variable at first, like an x. So 15 times 1 equals 15. And don't touch the chain in the first step. So leave the chain as the chain. So I'm jotting that down, and then I'm going to reduce 15 by 1 to 14. So that part of it is kind of like the power rule. The last step, though, is to multiply by the derivative of whatever is inside here. So that's not too hard because I can use the chain rule on it. Right? 3 times 3 is 9 times x squared plus 4, and that is it. Now keep in mind also that this is a derivative, so it's a slope. So if I had an x value to type into this, it would give me the slope of a tangent line at that point to this function that's up here. So nothing changes with the chain rule. It's still a derivative. It's still a slope. All right, let's look at a more medium example. These ones were kind of easy. We'll go medium next. All right, here is another instance in which we're happy to have the chain rule. If you look at the function I have on the right-hand side here, it's the cube root of this binomial squared. When I had these, I was trained to rewrite the equation first, or rewrite the polynomial expression as x to the 1/2, and then we knew that we could take the derivative of f by multiplying 1 times 1/2, and it would be x to the negative 1/2. You know, if we simplified it, it would be what? 1 over 2 times the square root of x. We don't usually do that because then now I'm dealing with a radical in the denominator. You know, do I simplify that? How far do you want to go on these? So at this point, this is where we've sort of taken the derivative. So we can sort of stop there. I can set this equal to 0 easy enough when we get to applications of derivatives. And if I wasn't comfortable with that, I'd write it this way. In any event, let's go to the right-hand side and look at this creature. This is hard to do if you don't know what you're doing yet. So what we're going to do is say x squared plus 1. Well, the inside power is 2, and the index is 3. Point at that. So I could write the 2/3 power. Now I can use the chain rule. I could say, well, f prime of x is equal to 1/2 times this chain. Again, I'm not doing anything to the chain until the next step. And then I have to subtract 1 from 2/3. So remember, 1 is 3/3, so 2/3 minus 3/3, that gives us a negative 1/3 power here. And the final step is to take the derivative of what is inside. So that just becomes 2x. So you're kind of done right there. You've taken the derivative. Some people would want it to be simplified. I could see where these 2's are going to cancel out. And then, let's see, I could rewrite it as x over x, well, let me redo that. X over the cube root of x squared plus 1. And the x squared plus 1 now is to the 1 power. So I just moved that into the denominator to change this exponent into a positive. But ordinarily, we can leave it like this. And if all we're doing is taking the derivative, you're kind of done at this point. All right, that was the medium example. Are you ready for the harder example? So here's one that's a little bit more challenging. Sometimes you actually have to combine some rules. So here we're looking at an expression that is x squared times x minus 2 to the 7th power. So obviously this section here, we've just been using the chain rule. However, we are going to have to use the product rule as well, because notice we have a product right here. So in the product rule, we say the derivative of the first times the second plus the derivative of the second times the first. So let's see how that goes. I'll leave that as red, pink. So the derivative of x squared, well, that is 2x. And I'm just multiplying it by the second function. So this is one function, this is another function. Next, we're going to add that to the derivative of the second. So I have to multiply 7 by this implied coefficient of 1. So that becomes 7 times x minus 2 to the 6th power. And where does that 6th power coming from? That's coming from 7 minus 1. Next, we would be multiplying this by the derivative of the inside. Now, sometimes it works out really nice like this, where you have x minus 2 is the inside, the chain, and the derivative of x minus 2 is just 1. So we ordinarily would not write that this way, but I'm just writing it to emphasize that I took the derivative of what was inside. All right, so there's the derivative of the first. Now we're going to multiply it by the second, which is an x squared. Sorry, I had to pause that for a second. That was my puppy barking. In any event, you could simplify this, I suppose. 2x. All right, that doesn't get any simpler. But over here on the right-hand side, I can multiply 7 times x squared. And I still have x minus 2 to the 6th. If I'm just taking a derivative, I can stop here. But if I'm going to set this equal to 0, I'm going to have to, like when I get to applications of derivatives, I'm going to have to factor out a common x minus 2 from both terms. So that gives us x minus 2. And the lowest number of x's is 6. So I'm going to take 6 of them out. And that will leave me with 2x times 1 factor of x minus 2, right? Because 7 plus 1, or 7 minus 6 was the 1. And then I'm going to go deal with this term. And I'd have, let's see, just 7x squared left, right? Because I took all 6 of these out over here. So what is nice about this is when we boil it down a little bit more, it's not an easy one to set equal to 0, but it's our best chance. If I kept on going, I could add my 2x squared and my 7x squared. So I still have x minus 2 to the 6th. And let's see, that would give me a 9x squared minus 4x. So if, say, later on I wanted to set this equal to 0, and we learned that later on in applications of derivatives, why would I want to do that? Why would I want to factor this? Is because I can use the zero product property. If this times that equals 0, either this is 0 or that is 0. Well, I have 6 factors of this. So I have x equals 2 6 times. I have a multiplicity of 6. Over here, we'd have to set that equal to 0 and solve it as well. So in any event, this is just showing you how far we're eventually going to have to take these. So that is one of the more challenging uses of where you have to combine a product rule and a chain rule. Okay, one last kind of, not hard, but different looking example. I guess you could call it a hard one. But when you're dealing with a trig function, what is inside the angle here becomes your chain. All right? So the first thing you're going to do is take the derivative of the sine of whatever this angle is, which is the cosine of this angle. But then the second step is to multiply by the derivative of what's inside. So that would just be a 5. So this would usually be written as 5, the cosine of 5x. So that's how it works when you have a trig function. Let's look at one more, a little bit trickier. Sometimes you will need to use the multiplication rule. So if I wanted to figure out the derivative of this creature, I'm going to say that dy dx is equal to the derivative of the first, which is x squared, 2x, times the second. So the second function is sine of 3x. Just going to write that down. Plus the derivative of the second function, so the derivative of the sine of 3x, is equal to the cosine of 3x times the derivative of this chain, 3, times the derivative of the first function that I'm